Right. Today discussion would focus on exception handling. Now, whenever we write a program, there is a possibility to occur that we don't expect. I write a simple program. We'll assume what I am going to do is I'm going to x to 10. I have defined a variable as x and I have given a value as 10. I'm going to print value of x and I'm right. All good, no issues. This is the standard or the usual situation that could be happen. So we are expecting this kind of a thing whenever we are writing a program. But there might be a situation like this. Int y is 0, and again what I'm going to do is I'm going to take x also to 0. Now x and y are two different variables and both variables are assigned to 0. What I'm going to do is x divide by y. Right. So computationally, uh, program can't understand a situation that there would be something gone wrong. Assume these are user inputs. Now since you can see what is the input, you can assume there would be some problem. But think these are two different places that accept in two different values, and the end user entered two different values at 0 and 0, but the logic is this one. So we'll see, like compile time we don't have any issue. We'll execute and we'll see what happens in here. It's not a love or it's not giving a proper value. It gives some situation that they can't handle. It's known as exception. You can see it's given a specific name, exception. An exceptional scenario for a normal circumstance. If it is like 10 divided by 0, then something gone wrong. Again, divide by 0. We'll go to the other way around. 0 divided by 10, then we can get a value as 0, because here the value is 0 is divided by 10, but in the other way around you're getting an exception. Correct. So this is something that we have to handle. This is a situation like these are I have added as static variables, but think these two are user inputs, then this kind of a logic might be a very serious problem. So what we need to do is we need to handle this kind of a situation, because we know this kind of a situation when the program executes. As an example, in this situation I have executed. Until the execution I can't see, I don't have any clue. But once it comes to the execution time, I can see exception in thread main, something gone wrong here. Java.lang.arithmetic exception. They're telling divide by 0 at animals.main. So they're telling all the story in here, what was gone wrong. They're telling during the main thread was execution. You know what are these threads now? There was an exception occurred, and they are telling what kind of exception was occurred. Exception was java.lang.arithmetic exception. So simply it's an arithmetic exception was occurred, and it's in the package of java.lang. What is the error that we have done is divide by 0, and where the line animals.java.9. So this is the place that we get into this big trouble. I'm not recommending go through all things and check, because there might be some issues in this output, some of the exceptions. But for this case it's perfectly giving where the actual issue was occurred. Now this is a situation that we need to handle. Think even a division can be a big problem. So above that, whatever input, scanner classes inputs or doing any other things, there might be a risky situation. Handling this kind of a risky situation is known as exception handling. How to handle this kind of a situation? My question is how to handle. We have a mechanism called exception handling. For the exception handling, we have mainly two keywords. One is try, the other one is catch. and we have an additional keyword code finally. Now, the today discussion would focus on majorly these three keywords. Now, what is try? This is like if, but don't misunderstand. This is not if at all, right? This is like if, a conditional situation kind of a situation, conditional kind of a activity happens in this try. This try scope. This is the scope starting. This is the place that scope starts, and this is the place that scope ends. See, so during this time, what we are letting to do is we are letting to do any kind of a risky thing, any kind of a risky code. As an example, now last time we were seeing, this is the place that some error can be occurred. So this is the risky point in our program, not these two. What we have to do is we have to take this risk, and we have to handle this risk, and we understood this is the place that risk can occur, and how to handle this risk. We have another keyword. Try is the keyword to let the risk. Okay, you just do the risky thing in here. Then if something gone wrong, we have another keyword called catch. Catch means whenever something gone wrong in here, you catch or you take the risk into this scope. If there's no risk at all, no issues, it completes the program and safely goes out. But in any case, if there is some issue occurred, then there's a problem. That problem should be handled in this scope, right? So what happens in here, we have to go for catch. They have given exception e. Exception is a class. It's a Java class. You can see java.lang.exception. This is the class that they have given. The class exception and its subclasses form the throwable that indicates conditions that are reasonable application might want to catch, right? So they have given some of additional information, whether these are checked exceptions and stuff, but I'm not going to discuss a detailed discussion. I'm just giving very high level overview today. So some of additional information also in here. If you are really interested, you can go for this hyperlink, then click, then you will redirect it to the relevant place, right? Somehow we'll come to, we just understood this is a class, and this is the reference variable of that class, and they have given a to-do line. Handle the exception. If you want to do something, you could handle during this time. What I'm going to do is I'm going to add another system.out.println with handled the exception. I'm giving an output. If something gone wrong here, I could get an output like handled exception, right? We'll see now. Last time viewers got an exception in thread main something blah blah blah, right? So we have done a small modification, and we'll see now what would be happened after this modification. What is the modification that we have done? We have added a try clause to add additional scope to handle the risky situation, and we have added a catch statement with a specific parameter. Then we have added a specific scope to give a notification if something gone wrong during this execution of this inside this try scope. We'll execute and see. Yeah, well, no issues at all. The program was successful end. As an example, if we added an additional system out here, uh, code exit, right? Now in this situation we can see there is a code exit, but if we do not add this try catch scope, I'll show you again. What I'm going to do is I'm going to remove this added situation. Now obviously we have the risk, it's open to the risk at line number 9. We'll execute this one, and see, after the line number 9 the program halts. The program won't execute at all. It's just terminated at line number 9. So it's a risky situation for the entire project. As an example, think we have 1 million of lines, but unfortunately line number 9 entire application was terminated. So it's a risk, it's a big risk. We have to handle this risk. How to handle this risk? We have to use this kind of a mechanism. Now even we have 1 million lines they execute, even we have a lot of issues occurred with the risky things occurred, we don't have to bother at all because it's perfectly working. Program runs throughout. As an example, if there are 1 million lines, all the 1 million lines are running accordingly. See, uh, there was an issue occurred, the same issue, I haven't done any modification, so that means some error occurred in here. So the catch scope handles that issue perfectly, and it completes without any issue. Then it goes to the next scope, end of this catch scope, like line number 17. The new scope starts. From the new scope onwards, the program executing very well without anything. As an example, we have 1 million lines in here, those are executing without any problem. That's the importance of this try catch. This is the try statement, this is the catch statement. Try means that if there's some issue, you have to add into here, and you can go for exception for something. Well, this is the high level structure of this exception handling, try and catch keywords. I'm going to do a small modification. What I'm going to do is I'm going to remove this manually added text. Instead of that, what I'm going to do is I'm going to add e. We'll see what is the output in here. Yeah, perfectly. Without any problem, we are getting some notification or some additional information. What is the problem in here? The problem is java.lang.arithmetic exception. Some exception was occurred. Divide by 0. So it gives nice information for us by taking this reference variable for this as this output. So we have some more advanced mechanisms, but I'm not going to discuss it. Those things, I believe even for a beginner could be able to understand. This is a very simplest method to get what is the issue or where the issue occurred, and additional information related to this situation. So the issue was occurred by the reason is divide by 0. This is a sample situation that I have discussed. Now shall we go for another one to discuss a bit more? I'll comment the entire story, and I'll go for an integer x array. So what I'm going to do is I'm going to add 1 2 3 and 4, right? Then I'm going to add a semicolon in here. Perfect. Then what I'm going to do is I'm going to print x zeroth index. So this is a simple array that I have added. Example 1, we'll go for a situation like example 1, we'll go for another one, example 2. Well, right, now we have another one, another situation. Divide it a bit more, right? Nice. Now we'll go to this one. Here we have defined an array named as x. Instead of that, we'll go for num. Define the variable as the array as num, and the values that takes for this num array is 1 2 3 and 4. So zeroth indexed, first, second and third indexes are there. So basically we have 4 elements, and 0 1 2 3 as the indexes that we have. And what we need to do is we need to take num 0 in the sense this is the value, right? The 0th index. So what I'm expecting is the output should be 1. We'll see what is the output here. I'll execute it. Yeah, perfectly. The expected output is in here. What I'm going to do is I'm going to take one step beyond this discussion. 0 1 2 3. So we can go for up to 3. Let's see, 3. Yes, perfectly. It gives the output as 4. What about 4? Now what I'm going to do is I'm going to access a variable without, like, with, I don't have a specific key for this. Or sorry, we don't I don't have what we call this index as 4, right? But I'm going to access. Now I'm getting into a trouble or an exception. What is the exception? Exception in thread main, again the same thing. They are giving some information. Java.lang.index array out of bounds exception. They are telling you have an array but it's out of bounds of the exception. Index 4 out of bounds for length 4. So they are telling I don't have an index called 4 and it's for length of 4. So where the issue is occurred, they are telling line number 22. Yeah, well, perfectly the issue was occurred in here. Right now I think you know how to handle this kind of a situation. We can add a try clause, and I'm going to add this risky situation inside this try. Then what I'm going to do is I'm going to add catch. Right, we'll add a catch. Again we have exception E. Since we know it's much easy to use this E as our output, what I'm going to do is I'm going to paste the same thing. Now I'll execute it. Yes, perfect. No issues. Java.lang.array index out of bounds exception. Index 4 out of bounds of 4 length 4. So we don't have a length. Assume we are going to for 5 or any other thing which is out of scope. Still, it could be handled perfectly without any issue. Now we'll assume another situation like something is not an exception. As an example, we are going for a 0, right? We are going for 0 index is in there, so this is the 0th index. So what I'm going to do is I'm going to execute in here. Yeah, perfectly. It starts with this scope, it comes to here. They have defined the array in here. Then they're trying to do a risky, like we was expected a risky situation, but in this time we don't have a risk at all, because what was happened, num 0. So what is the value? 0th index. 0th index means 1. So perfectly it takes the value 1 into here, then it prints 1 in here. In such instances we can't see there is there it comes to this catch scope and execute the program. Got it? Then system.out.println code exit, something happens in here. So I have given two examples for two risky situations. One is divide by 0, one is going out of the bounds of this array. Clear? So these are some of examples that we can happen, or we could expect in real world programs. So this is the program of a risk 1 and risk 2. We have handled these two risks by the exact same keywords try and catch. And for the exception that I have used the standard exception class as it is. We'll do some more modifications in future. Clear? Any questions? All good? We'll do a small modification now. What we can do is, I'll do the same modification for these two examples. What I'm going to do, I'm going to change this exception E into a narrowed down scope. What is the narrowed down scope? I'll let it to have happen another exception. I'm going to add 7 in here. I'm going to run it. Now java.lang.array out of bounds exception. So what I'm going to do is, instead of exception, what I'm going to do is I'm going to add array index out of bounds exception. What I have done is I have perfectly uh, tailored for this situation. Okay, so they are telling java.lang.array index out of bounds exception throw to indicate that array has been accessed with illegal index. So what is the illegal index? In this case, 7. Now initially I have used the exception class as it is. Instead of that, now what I'm going to do is I'm going to add array out of bounds array index out of bounds exception, a narrowed down one. We'll see what is this narrowed down and broader exception. Somehow this is an exception. What I'm going to do is I'm going to execute it. Yes, perfect. We don't want to just add this exception. If we want, we can tailor it for this specific situation. Well, in such cases, I'm going to uncomment this situation again. And what I'm going to do is I'm going to do take this one and I'm going to add it to here. Okay, what I'm going to do is I'm comment these things. Now I have x and y, two different variables. X is 10 and y is 0, and there is an integer array. This integer array consists of 1 2 3 4 values. Now what I'm going to do is I'm going to add two outputs, or I'm going to execute two statements. The first statement is mainly focused on taking an index out of this index scope. So there is a possibility, there's a high possibility is actually there must be something gone wrong. So we have experimented, we understood the error, or the sorry, the exception called during this array index out of bounds exception. To solve this one, what we have done is we have specifically tailored for this class. So now this exception was handled very well without anything. A small modification what I have done, what I have done here is I have added x divided by y. X divided by 0 means again there would be something or an exception. We experimented and we understood there is a risk, but what I'm going to experiment now, what happens for this array index out of bound exception, right? So what happens in here now, it's going to handle two things. The first thing is going out of bounds exception, the other one is divide by 0, and we can see easily this index array index out of bound exception is very clearly stated. But I don't have any idea what happens to this x divided by y, because the exception and in array index out of bound exception is two different things. So I don't know what could be happen. So we'll execute and see what happens in here. Yeah, perfect. It was handled. No issues in here. No issues in here, right? So array index out of bound exception, yeah, it was happened, and it was finished. Oh my god, so we are very happy now. No issues, right? No issues at all. So we'll do a small modification and check again whether we are happy or not. What I have done is I just took one line to up. Now we'll see what could be happen. Oh my god, something gone wrong. This program gives a nice clue for you. What is the program that gives a clue? The program gives a clue if there is something exception occurred at that line, the program halts or the terminates. It's not going to the next one, next line. Got it? The reason behind is there was something happened, yeah, well, an exception, and it goes to this catch scope, but it's not something that I can catch because it's two different things. Arithmetic exception, and I have defined something else, array index out of bounds exception. So these two different things, two different exceptions. So this program would terminate or the halts as it is, it's not executing at all. Previously it was successfully handled without any issue. See, previously it was handled. See what's the issue situation in here. The situation in here was initially there was an exception happened. The line number 22, there was an issue, and this issue handled by this scope, but this line number 23 wasn't executed. Got it? It wasn't executed. That's why the program is really happily running, no red lines and stuff. But what I have done is I have done a small modification. Now the story is totally different. right? Now the program is totally different. I have executed. Now the exception is occurring in line number 22, but unfortunately no one to handle this one. So comes to this catch scope, but unfortunately it can't handle this one. So it gives or the terminates the program without the expected output, at least this code exit. What we can do, we have to solve this kind of a problem. We'll add another catch. What about that option? We'll add another catch with exception E. Or else you can specifically cater for this arithmetic exception, but I'll keep this exception as it is. If you want, I can add this arithmetic exception. Arithmetic exception. Then instead of this to do line, we'll go for E and we'll execute this one. Now we have two different lines, line number 22 and 23. Both are risky. We experimented and learned. Both are risky, and we have two different things, two different catch options. Catch option one, cap option two. Right? We have to go for this either options. Now we understood this line would executed. There might be an exception, so it can handle in here. So my question is whether it goes to here and catch to this scope or not. Now it's a confusing place, right? We have two options. One is happening here. Then if it comes to here, then it goes to the rest of the things. That's it. There's no possibility to execute line number 23. But I'm not sure. So what I can do is I'll execute and see. Yeah, perfect. Java lang dot arithmetic exception divide by 0. Again, it gives a perfect confirmation. Practically, we understood it. If there are two or more exceptions, the first exception occurred. If it is handled by any of catch options, that's it. So it's not coming back to line number 23 and start execution again. So what you can do, what you have to understand is, if you believe if something is risky, go for the minimum number of scoped for this kind of a risky situations. As an example, if you believe that there are two different things, what I can do is I can take the entire this risky situation to another try scope. So at that time you are in a safe stage, because assume we are writing 1,000 lines after this one, right? That's none of the situation. It's guaranteed none of the situation these tanks would not execute, and whatever the stuff above this line number 22 is executing. It terminates as it is line number 22. Furthermore, it's not executing. So what you have to do is you have to take to the narrowed down scope. You have to take only to this risky line. You have to minimize as much as well. What about non-risky things inside a risky place? Any issues? Not at all. Not at all, because it's just non-risky. We know there is no possibility to have a risk at all. We have confident on this. If you are not confident, what you can do is you can go for a try catch, again another try catch, another try catch, another try catch, and so on and so forth. So you are in a safe stage, so you can do this experiment a lot more to find more and more different variations. Right. I have given an overview of this discussion, what happens with this try catch and how this try catch is working, and so on and so forth. Well, instead of writing these two catch uh, statements, what if we can go for an O operation in here? Since I'm really lazy, I'm going to add this one for E1. Right. Any issues? They are telling. I'll remove this catch as it is. Okay, it gives something E. Oh, delete this token. All right, sir. I'll delete that token. Okay, since I don't have this E, I'll add to change to E1. Seems okay. At the moment we don't have any issues, right? At the moment we don't have any issues. Compile time issues, no, zero. But we'll see what happens in run time. We'll run the program and we'll see. Yeah, perfect. Now what I have done, another variation. We have two different catch scopes or catch situations. One is array index out of bounds exception, the other one is arithmetic exception. What I have done is I have combined these two exceptions, and I told, even this happens, you go for this one, even this happens, you go for this one. Got it? Now, two different cases, one single reference variable in here. In such a situation, even this was right. Now it was changed the order. Now we'll see what has happened. Perfectly. Now it's handled in here. So we have multiple opportunities to catch all of these things. Got it? Now we are in a good stable stage to understand what happens in this array out of bounds exception plus O, this is O operation, O arithmetic exception occurred. Either options, it's handling very well. Now the problem is, think we have something, a large number of exceptions there. The exception class is a very detailed class. So we are unable to go for this array out of bounds exception or arithmetic exception or any other kind of a specificity of these exceptions. That's why what we are doing is, whenever something gone wrong, you don't want to add anything, you just go for exception. Exception is the most super. So even if it is array out of bounds exception, even if it is divided by 0, any of these exceptions are called by exception, because this is the most powerful and this is the most topmost class. So now if we execute it, no worries at all. What if this change modification for this uh, leaves perfect. Got it? That's why program automatically, if you just type catch, it automatically gives this exception class as it is, because we don't want to bother then after where or what kind of exception that we want to deal with. Got it? Now one more thing I would like to add to you a bit more for this situation. You can have this kind of a situation, like this kind of a uh, work also, if you are really interested. But now, since you know there's no point for this kind of a thing, right? We don't want to add multiple catch clauses, because one catch clause is more than enough. A big one. What if we can go for a specificity for this situation? Arithmetic exception in here. Arithmetic exception. Well, it's even and it's even. Is there any problem? If you are not sure, we'll remove this one. Yeah, well, still we are getting something error in here. What is the reason behind that? See, something gone wrong in compile time. They're telling remove catch clause, and or else they are telling replace catch clause with throws. Oh, they are giving some additional information here to fix. Why we need to fix unreachable catch block in arithmetic exception? It is already handled by the catch block for exception. So what was happened, this exception is almost like the most powerful exception class in the entire exception hierarchy. So what we have done is we have added it in the top. Now, whenever something occurred, even if it is divided by 0 or even if it is array out of bounds exception, regardless of any other number of exceptions, this exception class is going to catch those exceptions. Hence, there is no possibility that arithmetic exception will occur inside after this catch scope. What if we change the structure a bit more? I'm going to cut this one, then I'm going to paste it in here. Well, seems it's okay. Now it's okay. We'll execute and see. Yeah, again, seems nice, right? It's nice. Now, what was happening in this case? We have a small exception in here, the bigger exception in here. Now, if something is quoted by here, perfect, no worries at all. That's why this arithmetic exception is occurred. Right? We change the order. Now, before happen this arithmetic exception, array out of bounds exception will occur. Now, what happens in this case? There would be an exception, array out of bounds exception. It comes to here, arithmetic exception. No, it's not fit. We have understood it. Still, we have an opportunity to move or proceed further, so we can go for this exception class. And it, must be coded in this scope. We'll execute this one. Yeah, perfect, without any problem. It's nicely coded in this case. Got it? Now, whenever if we really wanted to have multiple exceptions to cascade, the lowest powerful or the most bottom in the hierarchy should be come to the top, and this should be come to the last. But as you can see, if we are just adding exception, it's more than enough. We don't want to go for multiple catch, or we don't want to pipe all of these catch instances for our exception handling situation. Clear? Right, questions? All good? Right. uh, we'll do a further discussion. Now you know what are these try and catch, and then you know different kinds of classes of these exceptions, and you know how to combine multiple exceptions in a one single try clause, right? So, and you know the value of this arithmetic exception, array out of bounds exception and exception classes, and the powerful or the hierarchy level of hierarchy of these exceptions and how it works, and so on and so forth. One more keyword that I want to add for the entire story. What we can do is I'll remove this arithmetic exception, since we don't want to bother at all. Right. It's gone wrong. Right. Okay. Right. Right. We have two risky situations and a one single catch statement. So we understood the whole story. What if we are changing this line number 7 to 2, and instead of 0 I'm going to add 2. Now comes to here, perfectly working, printing stacks, no output in here. It comes to here, it prints code exit. We'll execute and we'll see. Yes, perfect, no worries at all good, isn't it? It comes num2. What's that? So, something gone wrong. No. All right. So it's gone up. I was wondering where is number three. It was not in my screen. I was wondering, oh my God, who ate this one? Right. Perfectly. We have three because num two, 0, 1, 2. So it prints three, and here it's zero. Why it's a zero? Something divided by. Uh, since it's an integer, right? 0.5, change it to something valuable. Right. Now it's 1, perfect. 20 divided by 20, so it's number 1. So it prints number 1. It comes to this line number 25. It prints thanks, and no code executions during the line number 26 to 28. Now that there's no exception occurred, hence the line number 26, it directly jumps to line number 29 and start execution. Then it gives the output as code exit. Perfect. No worries at all. What I want to do is, I want to add this code exit even there is a try or a catch. I'll explain a bit more. What is that one? Add 0 by 0 thing, that's fine, and we'll execute now. Right, perfect. This code exit always gives the output because we are handling this one, isn't it? Since we are handling, even if it is a if it is if it is occurred for something like risky situation, still we have opportunity to execute. If we have some, if we don't have it risky, so it prints the output as it is. If it is a risky situation, it goes to this catch, then it handles. Somehow line 29 onwards, it moves to it. I want to state this try catch and a specific scenario, even there is a situation that occurred or not. I don't want to bother at all. I want to attach additional code for this code. As an example, if there's something gone wrong here or not, I don't want to bother at all. Somehow I want to print a specific output. So the specific output in this case is code exit. What I want to do is, I want to take this one out, then I'm going to add another uh, keyword known as finally. Going to add this one, try catch finally. Try, do this one, something there is no issues, you do it. Perfect. If there is an error, or so if there's something gone wrong, you come to this catch scope, you print it. Even there is something gone wrong or not, you have to give the output as code exit. That's the meaning of this finally. So this is try, catch, and finally statements. Right, we'll see and execute. Yeah, perfect, everything is okay. One more change I want to do. I'm going to remove this catch now. I'm going to introduce another structure, try finally. Now if you just keep try as it is, they are giving a compile time a problem. Sorry, try can't live long. See, try can't. See, syntax error, insert finally to complete try statement. They specifying, though this program do have errors or not, I want to state the last statements for something that's known as final statement. So you use this final statement. They are not proposing for catch. See, syntax error, insert finally, but actually it should be supposed to have exception. That's why we have added this kind of a statement, right? So what we have to do is, we have to add finally, though you are like or not, then you are in a safe stage. Even if you remove this catch, perfect. Now the risk is, again, a risk is something gone wrong, and the program is finishing. Though the program is finished, though the program is finished, you can see code is exited. Right? I'll show you. I'll do a small modification. I'm going to remove this finally statement now. Going to remove this finally statement now, and I'm going to add a catch statement again. Right? Going to add a catch statement here. Then the story comes the standard structure. Program to have try and a catch and something out of the scope. But in here, you attach to this one, so even if it is error or not, you are getting a specific output. So you can specify for end user the something with something if you want, but usually my general suggestion is never go for try finally. It's really really risky, really really risky. Never go for try finally, always go for try catch and finally if you really really wanted. um, but my general suggestion is go for try catch. Still if you want you can go for finally. The real usage of this finally is minimal for most of the codes device, right? So that covers the discussion related to the try catch and finally. So it gives an overview of this try catch and finally discussion. Any questions? All good. That's it then.